Welcome back to Java Internals Crashcasts. I'm your host, Sheila, and today we're diving into an exciting comparison between Java 17 and Java 21. We're currently in our Java version comparison season, and this episode is part of our comprehensive look at the evolution of Java. Victor, are you ready to explore the latest and greatest in Java?
Absolutely, Sheila. I'm thrilled to discuss the significant changes between these two major releases. Java 21, released in September 2023, brings some game-changing features that developers have been eagerly anticipating.
Before we dive in, let's start with a quiz question for our listeners. Here's a tricky one. In Java 21, how many virtual threads can typically be created on a system with 16 GB of RAM? A, thousands, B, millions, C, billions, D. It depends on the available memory. Think about it, listeners, and we'll reveal the answer at the end of the episode. Victor, what are your thoughts on this question?
That's an intriguing question, Sheila. It really gets to the heart of one of the most significant features in Java 21. Without giving away too much, I think listeners should consider the difference between virtual threads and traditional platform threads. The resource usage characteristics are quite different, which plays a crucial role in answering this question.
Great point, Victor. Let's start by giving our listeners some context. Java 17 was a long-term support (LTS) release that came out in September 2021, while Java 21 is the latest LTS release from September 2023. Can you give us an overview of the most significant changes between these versions?
Certainly, Sheila. Java 21 introduces several major features that significantly enhance the language and its capabilities. The standout features include Point 1. Virtual threads. Point 2. Pattern matching for switch expressions and statements. Point 3. Record patterns. Point 4. Sequenced collections. Point 5. String templates as a preview feature. These features aim to improve performance, simplify code, and provide more powerful tools for developers.
That's quite a list. Let's start with virtual threads, as it seems to be the most groundbreaking feature. Can you explain what virtual threads are and how they differ from traditional threads?
Absolutely. Virtual threads are a new lightweight implementation of threads in Java. Unlike traditional platform threads, which are mapped one-to-one with operating system threads, virtual threads are managed by the Java runtime. Think of platform threads as heavy-duty trucks, each requiring significant resources and overhead. In contrast, virtual threads are like lightweight bicycles. You can have many more of them without overwhelming your system. Virtual threads are designed to solve the C10K problem, handling many concurrent connections efficiently. They allow developers to write simple, sequential code that can scale to handle millions of concurrent operations.
That's a great analogy, Victor. So, if I understand correctly, virtual threads allow us to create many more concurrent operations without the overhead of traditional threads. How does this impact real-world applications?
You're spot on, Sheila. In real-world scenarios, this can lead to significant performance improvements, especially for I/O-bound applications like web servers or microservices. For example, imagine a server handling thousands of concurrent API requests. With platform threads, you might hit scalability limits due to the overhead of managing many OS-level threads. With virtual threads, you can potentially handle orders of magnitude more concurrent connections using the same hardware. Some early adopters have reported throughput improvements of 5-10 times in certain scenarios when migrating from platform threads to virtual threads.
That's impressive. Moving on to pattern matching, can you explain how the enhancements in Java 21 build upon what was introduced in earlier versions?
Certainly. Pattern matching has been evolving over several Java releases, and Java 21 takes it further with pattern matching for switch. This feature allows developers to use switch expressions and statements with more complex patterns, not just constants. For instance, you can now switch on the shape of an object and extract its components in a single step. Imagine being able to quickly identify and describe different types of objects like integers, strings, or even custom objects like geometric shapes, all within a single concise structure. This makes code more readable and reduces the need for explicit type checks and conversions.
That does sound much cleaner. It reminds me a bit of pattern matching in functional languages. Are there any pitfalls developers should be aware of when using this new feature?
Good observation, Sheila. Yes, it does draw inspiration from functional languages. As for pitfalls, one thing to be cautious about is exhaustiveness. The compiler checks if your switch covers all possible cases, but it's still possible to miss logical cases if you're not careful. Also, while pattern matching can make code more concise, it's important not to overuse it to the point where it reduces readability. As with any powerful feature, it should be used judiciously.
Thanks for pointing that out, Victor. Now let's talk about sequenced collections. What problem does this new API solve?
Sequenced collections address a long-standing inconsistency in Java's collections framework. Before Java 21, different collection types had different methods for accessing elements at the beginning or end of the collection. The new sequenced collection, sequence set, and sequenced map interfaces provide a unified API for collections with a defined encounter order. They introduce methods like adding to the start or end of a collection, getting the first or last element, and even reversing the collection order. This makes it easier to work with collections in a consistent way, regardless of whether you're using a list, deque, or linked hash set.
That sounds like it could simplify a lot of code. Are there any performance implications to using these new interfaces?
Good question, Sheila. In most cases, the performance impact should be minimal. The new interfaces are implemented by existing collection classes, so they're mostly providing a new API layer rather than changing the underlying data structures. However, developers should be aware that some operations, like reversing a collection, might create a view of the collection rather than a new copy. This can be more efficient for large collections, but might have different performance characteristics in certain use cases.
I see. Before we wrap up, can you briefly touch on string templates? I know it's a preview feature, but it seems interesting.
Absolutely. String templates are an exciting preview feature in Java 21. They provide a more flexible and powerful way to create formatted strings compared to the current string concatenation or formatting methods. Imagine being able to easily insert variables or expressions directly into your strings, making them more readable and less error-prone. For example, you could create a greeting message that includes a person's name and age, all in one simple, easy-to-read line of code. This feature is still in preview, which means it's not finalized and might change in future releases. However, it shows Java's direction towards more expressive and convenient string handling.
That does sound convenient. As we're nearing the end of our episode, let's reveal the answer to our quiz question. Victor, would you like to do the honors?
Of course! The correct answer to how many virtual threads can typically be created on a system with 16 GB of RAM is B, millions. Virtual threads are so lightweight that you can typically create millions of them even on modest hardware. This is because they don't have a one-to-one mapping with OS threads and use very little memory overhead. However, the exact number can vary depending on the specific use case and system configuration.
Thank you, Victor. To summarize today's episode, point 1, Java 21 introduces virtual threads, a game changer for concurrent programming. Point 2, pattern matching for Switch enhances code readability and expressiveness. Point 3, sequenced collections provide a unified API for ordered collections. Point 4, string templates in preview offer a new way to create formatted strings. These features represent a significant step forward in Java's evolution, focusing on performance, developer productivity, and code clarity.
Absolutely, Sheila. Java 21 is a landmark release that brings Java closer to modern programming paradigms, while maintaining its core strengths of reliability and performance.
Thank you, Victor, for your insights. In our next episode, we'll be looking at the changes between Java 21 and Java 22, exploring the latest developments in the Java ecosystem. Listeners, don't forget to subscribe to Java Internals Crashcasts and leave us a rating if you enjoyed this episode. Your support helps us continue creating in-depth educational content about Java internals. Until next time, happy coding!